Alright, so this is everything hooked up. Uh, that shows an example of switches, and these are my switches over here. So these would be like door sensor switches that go into the door that depress when the door is closed and open up when the door is open. So here's a complete working setup of everything from a high level, everything hooked up together. So let's start with the power supply. So this is an AC adapter going to DC power, 12 volt DC power. So 12 volt DC power is coming into here. And then here I have a splitter for negative and positive. So the red positive is going to the red terminal here, the red terminal there. And then I have a comb, wire comb attached to all those terminals on that side. And then that just means the power is coming in between these pairs and these pairs. And those pairs are hooked up to the red wires going to two switches. So here I have the power split into two terminals going to two switches. And then the negative is on the left here. The negative, or the top, is going to this 1 minus on the optocoupler board. So this is an optocoupler board. 4 channels, 4 separate channels for 4 separate inputs. I have it wired where the positive is my input signal. So 1 minus comes in as the negative terminal, and then I just daisy chained the negatives over to 2 minus and 3 minus with just a black wire that I just loop right over into the next negative terminal. And then the positives are coming in from these resistors that are coming from the switch. So, and they're wired up the same way. So I have a negative, or the positive line coming in, going through the black wire to the resistor back into the positive of the optocoupler board. So now when I press this, the light comes on for zone number 2, and this is zone number 1. Oh, you press that. Press that. You can see it over there. Zone number 2. And you can see it light up over there. And also you'll notice that on the board here, on this side of the board, it was also lighting up. So this is the 3.3 side of the board. So 12 volt coming in, 3.3 coming in over here. Here I have VCC, or the 3.3 volt coming from the GPIO board here, with the red pin, or the red jumping wire. The red jumper wire comes in here to the VCC. The green jumper wire you see hooked into the blue terminal of the ground, that's hooked up to the ground of the board. Oh, I'm sorry, did I say, yeah, the green jumper wire. The green jumper wire comes over here to the ground, right there above the yellow, and below the 3.3 where it says G and D there. And then the next 2 wires, the yellow and the blue, are just input wires to O1 and O2, which is the output signal from the 12 volt side of the circuit. So we've got the 12 volt side of the circuit and the 3.3 volt side of the circuit. 3.3 side of the circuit is coming in to, you guessed it, the Raspberry Pi. This is a 3B plus model, and I just have ribbon cables connected in to the Raspberry Pi with the red T hooked into this breadboard, which makes it easy to connect everything up. So now I have GPIO pin 27 and 22 hooked up to zone 1s and 2. And then if you come over here to the program, I have a program here that will run and just loop and just constantly check the input pins. Check 5, input pin number 27 and 22 are reporting 0 values. So let me press zone 1, and then zone 1 is reporting that zone 1 is hooked up to the pin number 27, and 27 you see is returning a value of 1. And if you can see here, it's red and red on either side of zone 1 on the board. Everything's working. Now let me press zone 2. I'm pressing zone 2. The red light turns on both circuits, come up to the pin, reports it to the Pi and into my program. Oh, and look, it's 1. And the 27 flipped back to a 0. So if I let go now, it'll go back to 0. So this all works, and this is just a test of a mini-scale test of hooking up door sensors to the Raspberry Pi and then controlling it through the program.